All right, guys, now after studying the RC phase shift oscillator, we are now going to understand the next type of oscillator, which is called the Wein bridge oscillator. Okay, so again, the Wein bridge oscillator is a type of harmonic oscillator, or you can say it's a sinusoidal oscillator. So your output waveform is again a sine wave, right? The circuit diagram for this oscillator would be that you have the negative side, which would have the R3 resistor and it's connected to the ground. You would have a feedback coming up. I'm going to say that it is an R4 resistor that is connected over here to the output terminal. All right, so for feedback or for beta, we have a resistor, a capacitor. I'm going to say that's R1 and C1. Then it's coming back over here, but before it comes back, it has a parallel capacitor and a parallel combination of resistor with ground. So that's my R2 and that's my RC1, C2, right? R1, C1, R2, C2, R3, R4, right? These are all my combinations over here. Before we go further ahead, let's try to analyze this circuit that I have drawn over here, which is what? Which is my beta circuit, right? So this beta circuit over here is nothing but it's just a series C1 R1 and then a parallel C2 R2, and this is where you have your output. That's your input points. So as you can see in this beta feedback, we have C1 and R1 in series. So that's the RC series circuit, which is nothing but that's just a high pass filter. And over here, the parallel combination of resistor and capacitor is nothing but just a low pass filter, right? So it will only allow certain value of frequencies to pass because both of the filters are embedded in the feedback, which is the high pass and the low pass, right? So it will only allow one specific frequency, and that is called as the resonance frequency. That will be FR. It will only allow that, right? So probably you would look at the response somewhat like this, that you have no frequencies and you have a very high frequency with the maximum amplitude, and that is the resonant frequency value over there, right? For this circuit out there. All right, so for this circuit, since we know that R and C would eventually create a phase shift, but again, the parallel combination would cancel that phase shift. So we would have a phase shift of nothing but 0 in that circuit. Another important conclusion for the circuit over here, just for this, is that V out over V in is basically equals to 1 over 3. You can do the derivation if you want to, but I'm just quickly going to tell you that this is 1 over 3. So this 1 over 3 is equals to nothing but my beta value, right? So this beta value is nothing but 1 over 3 in this circuit. All right, with that being said, there are a few things that you should try to understand. Now, if I have a beta value, second, yep. So now if I have a beta value of 1 over 3, I know that for the oscillator to be stable and keep on running for a longer time, I should have the A beta value equals to 1, right? So from this equation, I can actually figure out the value of A. So this is A times 1 over 3, which is fixed for beta, should be equals to 1. So the gain of the op amp should be equals to 3 from this equation. All right, so as you know, for inverting amplifiers, we have the equation that A is equals to 1 plus R4 over R3, right? Here we have a combination of resistor 4 and resistor 3, as you can see over here. This is the combination of resistor 4 and resistor 3, right? That's why we have used the same values over here. So for A is equals to R4 over R3, I can say that A is 3 from here, 1 plus R4 over R3. So R4 over R3 combination would turn out to be nothing but just at a 2 value, right? So R4 has to be double of whatever the value we select for R3. All right, that's the first thing. Now for second thing, if we consider that we have two resistors and two capacitors in the circuit, right? So if we consider that the resistor 1 is equals to resistor 2 and capacitor 1 is equals to capacitor 2. So I can use the formula for resonant frequency, which is 1 over 2 pi RC. That's my formula for resonant frequency. And even if you don't want to use the same resistor values, R1 and R2, and the same capacitor values, then you would probably need, else if you don't use this thing, then you have to use the longer formula, which is FR is basically equals to what? 1 over 2 pi root R1, R2, C1, C2, right? So that you have the mean value of the resistors and the capacitors. So this would actually be useful in design questions that we are going to do right next up. All right, so this is the circuit as you can see over here. I'm going to just put forward down design question that says design a Wein bridge oscillator of frequency is 10 kilohertz, right? So first thing is that I'm going to say that I'm going to do it with the simple steps. That's R1 is equals to R2 and C1 would be equal to C2, nothing else, right? Then we have the both value of them are same and my frequency is basically what, 10 kilohertz. So I'm going to use the formula for my resonant frequency, which is 1 over 2 pi RC. Like always, I'll pick the value of capacitance, this time maybe 0.01 microfarads. Substitute that capacitance over here. Resistance needs to be figured out. FR is already given at 10 kilohertz. So I'm going to just make R as a subject. That would be 1 over 2 pi FRC, which is 1 over 2 pi, frequency is 10 power 3 times capacitance is 0.01 times 10 power minus 6, right? So that will give me an answer of resistor value, which turns out to be 1.59 kilo ohms, right? This is my resistor value. So the R1 and R2 are both same at 1.59 kilohertz. The C1 and C2 are both now same at 0.01 microfarads. We have done a lot of part in the circuit, right? So we have figured out the beta over here, C1, R1, C2, R2. Now it's just remaining part is the gain, which is very pretty simple, right? We have already concluded that R4 over R3 should be equal to nothing but just 2 because of the circuit, right? So I can say I can use a 20 kilo ohm divided by 10 kilo ohm resistor to get a 2 ohms, right? That would be my R4 and R3. So now I have my R4, R3, which is the gain resistors. I have my low pass, high pass combination resistors, C and R, and I have designed that on the basis of 10 kilohertz frequency. So yeah, this circuit is the Wein bridge oscillator that can oscillate at the frequency of 10